All right, welcome to today's virtual user group, F5DOD, otherwise known as the VUG. My name is David Thomas. I am your host today, and I'm an account manager covering DISA for the DOD team at F5. I'm really excited to be back today. This is actually our 11th virtual user group in a series that started in April of 2020, right after the pandemic, telework and shut down remote working from home. So we really appreciate everyone who has attended these over the course of this year. And it's something that we see as very successful and something that we'll continue to nurture and foster throughout the remainder of 2020 and into 2021. We're already starting to plan out several different user groups and technical enablement sessions that will get us well through winter and into the spring of next year. So we really appreciate you being here today. We could not do it without you, the end user, and without our amazing technical staff and engineering team at F5. So a big warm welcome to everyone on today's call, and a big thank you to all the F5 engineers who really take a lot of pride and put a lot of effort into these sessions. So some of the goals from the technical enablement and virtual user groups are really to stay connected with you and to take a human first approach for F5, right? We understand how challenging these times can be. We aren't going into the office anymore, and there's no more handshaking or high fives or even seeing our colleagues in person. So this is the best we can do right now, and we really want to stay connected. So if there's any ideas you have out there to further some of these technical enablement sessions, let us know. But we're going to keep these going on a regular basis to stay connected and really work with a human first mantra. So a couple things before we get started. I'll share my screen here in a second and just walk you through some housekeeping. One thing that's not in those slides, though, is continuing education. Keep in mind that for each hour of training you receive from F5, you'll receive a continuing education credit. So we can submit on your behalf if you provide us with your CSIP ISC squared number, or you can go self-submit to whatever governing body holds your accreditations and certifications. So keep that in mind. If you have any questions, let me know, and we can help you get those continuing credits. So let me walk through some of the housekeeping just to keep you up to speed on what we're going to be doing today from a let me start here. Just from a Zoom perspective, I know a lot of you have worked in Zoom with us in the past, but there's a couple really cool features that will keep it very interactive throughout the course of the day. So in the training. So first off, there's two features here. If you look down at the bottom of your screen in Zoom on that toolbar, there's a couple radio buttons to keep in mind. The chat button, any question you have, there's no dumb questions, put it in the chat, right? We have a team of engineers on today that can help support you and get the questions answered. And yeah, you can ask it directly to an engineer, to someone, or just throw it out to everyone. Really, the best way to ask the question is just to chat it to everyone. Okay, the next really important piece here is breakout rooms. So when we'll start off with a presentation today. Saad Khalid will be delivering the presentation on programmability and REST. And during that prezo, we'll just go through it a few slides. Following that, we'll go right into the UDF lab. And when we do that, we'll set up a couple different breakout rooms so that if you have a question and you need to ask and use your mic and talk to one of our systems engineers, you can do that through this breakout room. So we'll set up the breakout room and we'll take care of assigning you to that breakout room once that starts. Really important piece here to remember: when you're done with the breakout room, make sure you don't leave meeting, you leave breakout room. Once you leave the breakout room, you'll be brought back into the main group. You can use you know, a couple different browsers, Chrome and Windows. And then UDF, if you're having any challenges with your UDF, that's a great place to ask in the chat. We should have registered everyone here. It looks like there's over 40 people who are on right now. So, so you can go ahead and register here. And if you have any issues, just let us know and we'll help get you sorted. Anthony Graber's been working on that this morning. So I think really that's it. You know, let me stop my share. Saad, you can get your slides back up. We have a full team of the F5 DoD engineers on today. Today's discussion will be led by F5's automation orchestration specialist, Saad Khalid. You've probably heard from him a few times in the past. He's done a lot of work within the DoD and specifically within DISA. So, you know, we're excited to have him here today. We also have members from the Air Force team, Paul Deacon and Arnulfo Hernandez. Our DISA engineer, Anthony Graber, will be here today. From Army, we have Michael Slavinsky and Sean Simmons. Navy, Paul Simmons and Jimmy Jennings. And then from our Pentagon D agencies, we have August Winterstein. So thank you so much. Saad, let's take it away and have another successful VUG. So thanks so much. And we look forward to talking with you soon. Bye.
Cool. Awesome. Thank you, DT. And hey, everyone, thank you for joining. So as DT mentioned, my name is Saad Khalid, and I'm a solutions engineer here at F5. And so today's VUG is going to be on intro to Big IP REST concepts, and then we'll dive into our automation tool chain. And so in this lab, it's going to be mostly a hands-on lab, so I'm not going to be up here speaking for too long. But in this lab, we'll review some automation and orchestration concepts, and we'll learn some basics of REST, which should be reviewed for most of you. And then we'll dive into module 1, where we will do some imperative automation. And then about an hour into the course, we'll come back for about a 5-minute lecture where we'll explore declarative APIs, and I will introduce AS3. And then we'll end with the module 2, where you will work hands-on with AS3.
Is your camera on?
Yeah, I can turn my camera on, but if my audio lags, I'll probably turn it off when I have my screen share. Right. Yeah, okay. My bandwidth is bad, but I'll keep it on for a bit. If I lag, I'll turn it off. So the main goal for today is to elevate your knowledge of automation basics, specifically with your F5 devices. So before we get into the intro to REST, let's just level set. And I want to begin by demystifying some automation and orchestration terms, mainly automation and orchestration. So automation is all about codifying tasks. And so it's all about single task. It's oriented around single tasks being automated, such as instantiating a virtual machine or installing a web service. And then you have orchestration, which is all about codifying processes. And so orchestration really takes advantage of automation by reusing these basic building blocks, kind of like Legos. And so orchestration is all about tying multiple automation tasks together to complete a process. And so you're probably wondering, well, why would we want to do this? And I'm sure most of you are familiar with the pros and cons of automation. But you really want to automate because it reduces deployment times, it reduces your OpEx, and it reduces human errors, while also providing an increasing consistency. It reduces your time to market so that you can be more agile, and it allows you to scale to meet your customer demands. But put quite simply, automation just makes your life easier, so use it, right? It saves you your most important resource, which is time, and then you can use that time to focus on tasks that actually matter to you. How's my audio, by the way? Am I lagging?
No, sounds good.
All right, cool. So when we're talking about automation, it's important to understand the two interfaces of automation. So there's imperative and declarative. So imperative automation is what we've been doing for many years. It's scripting, and it's essentially where you tell the system what you want to achieve, but you have to hold the system's hand, and you have to tell the system every step you need to take to get to that end desired goal. And one analogy I like for imperative automation and defining the difference between imperative and declarative is the sandwich analogy. Essentially where if you think about making a sandwich, you're responsible for grabbing all the raw ingredients and then following a recipe to create that end product. And if you make that sandwich, say twice a week, 3 times a week, but you don't exactly follow that recipe in order, you're not necessarily going to get that same end result. Meanwhile, declarative is what we're evolving to, a declarative interface. And if you worked with CloudFormation templates on AWS or Azure Resource Manager or ARM templates on Azure, you're probably familiar with the declarative interface. And it's essentially, instead of you telling the system every step of the way what you want, you essentially define in a text-based file, usually a YAML or a JSON file, what end state you want to achieve, and then you let the system figure out how to achieve that end state. And so going back to our sandwich analogy, instead of making the sandwich yourself, let's just say you pull up to McDonald's and you order a cheeseburger and you don't care how it's made, you just care about getting your sandwich. And so you can really start to see the benefits of declarative automation because you don't need to be an F5 expert or have any of that domain specific knowledge or worry about what comes first, the pool or the pool member and so on. It also speeds your deployment process and it requires fewer API calls. And most importantly, it makes it easy to integrate the deployment of F5 services into a broader orchestration system. One other concept is source of truth. And it should be reviewed for most of you, but if you're not familiar with source of truth, it's essentially, the definition is a system or object that contains the authoritative representation of a service. So simply put, let's just take an example. So if you're using, let's say, Ansible playbooks to do your configuration management via the API, you're using those Ansible playbooks, and those playbooks are your source of truth. So once you create, let's say, a virtual server using those playbooks, and then you go into the GUI to make some sort of modification or you make a deletion, that's referred to as an out-of-band change. And so once you begin using the API to do your configuration management, it's highly recommended to completely avoid out-of-band changes so that you don't break things. And so when you're using something like AS3, which I'll introduce in just a moment, those AS3 declarations, those JSON-based text files become your source of truth. So let's do a quick introduction to REST. This should be a pretty basic overview for most of you. So REST stands for Representational State Transfer. It's essentially an architectural style for providing a standard between computer systems on the internet so that they can communicate more easily. And so when you're making a request, REST requires that a client makes a request to the server in order to retrieve and manipulate data. And so a request typically has 4 parts to it. It has an HTTP verb, which could be a get, a post, a put, a patch, or a delete. And then you've got headers, and then a path or a URI to the resource or collection that you're trying to act on. And then an optional message body, which is depicted by a JSON format. It's important to note also that RESTful systems are characterized by how they are stateless and how they separate the client and the server. And so the fundamental concept in RESTful API is a resource and a collection. And so a resource is an object with a type, some associated data, and relationships to other resources. And this table gives a generalized overview of what different types of HTTP methods would do if called on a collection or a resource. So for example, if you perform a get operation on a collection, it'll return all of the resources in that collection. Whereas if you perform a get on the resource itself, it gives you the resources representation. And this will make more sense in just a moment. And so when we're looking at the anatomy of a REST URI, you've got your root. So in this case, it's the big IP address as well as slash management. And then you've got the organizing collection, which is traffic management LTM. And then you've got a collection, which is your pool. And within that collection, you've got your resource, which is my pool, which is your actual pool. And then within that, you've got sub collections and sub collection resources. And so the resource is the actual pool itself. And so looks like I skipping a slide here for some reason. So response code. So when you're working with with a RESTful interface, you will have response codes, HTTP response codes. And so I've just listed a few basic ones here, the main ones. But usually when you receive a 200 OK response, it means everything is good. A 202 means something is in processing, it's been accepted, but it's something's happening on the server end. And then you can get your 400s or your 500s as well. This is just kind of like a brief overview. I don't expect everyone to memorize or know all of the HTTP response codes. And so how is the REST API actually implemented on TMOS? Well, so the REST API, essentially, the REST API attributes are derived from the traffic management schema. And generally, anything that you're able to accomplish from the command line, you can leverage programmatically with iControl REST. And here on the bottom of the screen, you can see an example of how a TMSH command actually maps to an API call. Okay, so I believe my audio is fine. I don't think I'm lagging. That is pretty much it for the first section of the lab. What we discussed here is essentially some basic REST concepts. And so the rest of what you guys are gonna do and learn is gonna be through the lab guide and the lab itself. And so hopefully you guys have all joined the UDF course and launched the UDF deployment itself. It does take about 10 minutes to start up. So if you're seeing it spin with a yellow shaded area, it just means it's spinning up. If you haven't received an email with your UDF information, please let one of us know so that we can get you that appropriate information. So what we'll do is we'll break into labs for about 40 minutes, and around 2 o'clock, we'll join back for about a 5-minute lecture again, where I'll introduce declarative interfaces and F5's automation toolchain, and we'll discuss AS3, and then we'll dive back into the lab for the remainder of the course. Do I have any questions right now? So this first lab will explore the iControl REST API, and you guys will basically build a basic big IP LTM config using Postman. And all of this is going to be imperative automation, and you'll begin to see and get familiar with the REST API and how to interact with the big IP. But then towards the end, you'll probably see the pros and cons of imperative automation, and then we'll dive into the declarative automation interface. And so once you guys are on the UDF course itself, you'll see this screen right here, and you'll see a documentation tab and a deployment tab. If you're having trouble just getting to even this screen, please let one of us know so we could walk you through how to get there. But there's going to be two lab guides up top, and the one we're doing today is the Introduction to REST, Big IP Structures and Concepts. It's going to be the class 1. So you're going to open this up, and when you click the deployment tab, here you'll see all of your components in your deployment. And so over here with the Windows 10 jump host, you're going to want to click Access, and you're going to choose your preferred screen resolution for your RDP. And I'll go ahead and I'll share my screen, and I'll have all of the credentials up here so you guys don't have to switch between tabs. Yep, so I'm seeing in the chat, someone saying about spinning yellow gears. That's normal. It's gonna take a couple minutes to spin up so that it's green. So if it's yellow, that's completely normal. Yeah, so it looks like there's a little bit of confusion about what lab we're doing. So when you're on your UDF course itself, up at the top right here under documentation, you're gonna click the link where it says class1.html. When you open this, it'll take you to this page, and you can go ahead and just navigate through it. Just completely ignore the side left tab right here. These are different courses, but you're going to just want to use the next and previous buttons. And so you don't have to worry about the lab topology. I'll keep this screen up so that way you guys have all of your credentials here. You don't have to go switching between tabs. But you're going to start with module 1, imperative automation with big IP and iControl REST. It's going to be module 1 is from labs 1.1 to 1.6.
All right, Saad, I'm going to go ahead and pause the recording for now, if that's okay. And then we'll pick it up when you kick off the next section.
Yeah, sounds good.
All right, let's play a little music for everybody while they get in this lab. So I'll pull something cool up.
Okay, so as you guys have already learned through experience, the first portion of this lab is imperative automation, and it's not the most exciting thing in the world because it still requires a lot of tedious work and stuff. And so this is where, let me skip to this next slide. So you're probably kind of feeling like this.
I think you need to go into prezo mode, Saad.
Oh, you can't see my screen. Give me a sec.
I'm sure. Just give it a second. I'll let you know when it's on.
Let me stop and reshare then. Looks like I'm sharing.
There you go.
Okay.
You're good.
All right, cool. So yeah, so you guys have learned through experience that imperative automation can still require domain-specific knowledge and is still tedious. And so this is where declarative APIs really start to shine. And so F5 is taking a declarative approach to automation. And we have an automation toolchain, which is a set of open source automation tools. Let me turn my camera on. So we have a F5 automation toolchain, which is essentially a set of automation open source tools that makes it faster and easier to both configure and deploy your app services via a declarative interface. So the automation toolchain mainly consists of 3 open source tools. There's declarative onboarding for your layer 1 to 3 device provisioning. There's application services 3 extension, which is for your layer 4 to 7 configuration. And then there's telemetry streaming for aggregating and forwarding your data to third-party analytic tools. And we have integrations with products like Splunk and Elasticsearch and many more. And again, these the automation toolchain is available. It's open source and it's on GitHub, and it's supported by F5. And so the toolchain really enables developers to programmatically extend F5's application services, and also to ease the integration with CI/CD toolchains, orchestration systems, and other third-party ecosystems. So one of the main benefits of AS3 and its declarative interface is that it minimizes the need for domain-specific knowledge specific to the big IP. And that's because, as you'll see on the next slide, you essentially define one JSON-based text file with your end result, and then you send one API call and you let the system figure out how to achieve that end state. But most importantly, AS3 provides a sustainable foundation for infrastructure as code strategy for your organization, and allows for future integrations with third-party orchestration solutions. So in lab module 1, you guys did a lot of this where you're configuring the big IP with a bunch of API calls. And so as I've mentioned a couple of times already, this is really time consuming. It can be error prone, as you saw when I had, we have all these people saying, oh, I missed a step, or I did this, I did that, this is not working. It's because it's very error prone. You have to follow every step. And you're creating many API calls. But with AS3, all of that changes. So AS3 abstracts all of that complexity away. And so essentially what you have is one JSON-based text file where you define what you want. So you define, following a specific schema, your virtual servers, your pool members. And then you send one API call, and then AS3 or the system will figure out how to get you to the end state. And this is really, really beneficial because, as you'll see in this next lab, these declarations are reusable. So it not only reduces errors, but ensures consistency. And it requires minimal big IP domain specific knowledge. So the AS3 API endpoint is shared app services declare. And one other thing to note, two things to note is that AS3 is atomic and idempotent. So atomic meaning it's all or nothing, and idempotent meaning that even if you perform the same, if you send the same declaration like 200 times, the result will always be the same. And Big IP, as most of you may know, is multi-tenant inherently, and AS3 supports this multi-tenancy. And so now what you see is we're going from this traditional GUI for all your configuration to a JSON-based text file. And this text file can actually be a part of a larger CI/CD pipeline with proper source control in order to allow you to orchestrate and do what you need to do in your environment. And so that's it. So let's dive into module 2. During the lab, in the lab guide itself, it explains a lot of the questions you may have in detail as you're learning about it. And if you still have further questions, feel free to ask. I think I'll let you guys start the lab itself, and maybe in 10 minutes, I'll share my screen and go through the lab as a whole. And so in this lab, it's 3 sections. First, you'll just explore AS3, then you'll install AS3. And so there's multiple ways to install AS3. It's available as an RPM on GitHub, and you can install it manually with the GUI. You could use a script, or you could use the REST API. And you'll see all of that in Lab 2.2. And then in Lab 2.3, you'll go ahead and start actually playing around with the declarative interface, and you'll see the huge difference between the imperative interface and the declarative interface. All right, so we're coming up to the top of the hour. So I'll go ahead and start with some concluding statements. For those of you who haven't gotten through the entire lab, don't worry, you still have about 5 hours before the lab starts to delete itself. So if at some point later today you want to go back in and run through the lab, you can do so. And if at any point in the future, if you would like to run through the lab again, just reach out to your SE, and we should be able to stand up an environment for you to be able to do that at another time at your own pace. So what you guys saw here today was, let me see, here we go. So today we learned basic concepts of how you can interact with the REST API on the Big IP. And then in lab 1 or module 1, we walked through an imperative automation flow where we explored the REST API, and we used the runner functionality in Postman because we saw that with imperative commands, it's still pretty tedious to send multiple imperative commands. And then we dived into AS3 and the F5 automation toolchain, and we worked with declarative interfaces, and we saw the night and day difference between sending declarative APIs to the Big IP versus the imperative interface. And you saw how much less tedious work you have to do, and how it's much simpler to just have a text file defined with your end state and letting the system figure out how to get there. Now, I'm sure some of you haven't gotten to go through Lab 2.3, and that's okay. Please do go through it at some point later today. It should not take more than maybe 30 minutes to an hour if you've got 2.1 and 2.2 set up. And I hope you guys learned something about automation today. It was meant to be a pretty basic intro course. We do have an advanced automation course on the toolchain where you could get more hands-on experience with declarative onboarding, AS3, and telemetry streaming. And if you're interested in future bugs, I'm gonna hand it off to DT. He'll talk a little bit about some upcoming sessions that we will have in the upcoming months.
Hey, thanks, Saad. Yeah, and really appreciate everyone's time today. Like Saad mentioned, we're going to keep the labs open until about 8 o'clock tonight. If you have any questions, need any assistance in there, let us know. You can, just reach out to someone on the team and we'll get back to you. So on the screen, we're running through some of our topics and courses that are upcoming in the next few months. You'll notice there's a lot of different events. So, we got ahead of the game with these virtual user groups. But now F5 Corporate is really starting to catch on and drive a lot of the same sort of one-to-many virtual sessions for end users. So a lot of these are corporate driven. They're not federal DoD specific, but they're still very valuable. So you'll see a lot of Big IQ training on there, a lot of Ansible F5 workshops on there. Those are Pacific times. Note that if you want to register. We also have a certification boot camp that's scheduled on October 27th. That's an excellent course if you're interested in going after an LTM Essentials training. And then there is a 201 certification boot camp as well on October 29th. So plenty of trainings in here for you to access. We're also working on future VUGs or user groups that'll take us well into the spring. Once those are ready and published, we'll send those out to the group. And of course, you can always access previous recordings on the F5 DoD Virtual User Group page. You should have a link to that in the email invite that you received. But you can go back and view all the recordings. You'll get, if you need access to the labs, let us know. And all the PowerPoint presentations will be there as well. So that's it for today's virtual user group. Let us know if there's anything else we can do to help assist in the future. But, really appreciate your time and we'll be in touch soon. So thanks so much, Saad. You did a great job. And to all the engineers supporting today, thanks. And of course, everybody attending, we really appreciate your time. Have a great day.
Yep. Thanks everyone for your time and thanks for joining. We'll see you on the next VUG.
Thank you very much.
Got it. Thanks, everybody.